All right, let's start chapter 12. Lesson 1 is over square root functions. Mainly we're going to be graphing these, and you need to be able to evaluate square root functions as well, but I don't think you'll have too much of an issue with that. Okay, here we go. So we're being asked to sketch the graph of y equals -2 times the square root of x. And we're also being asked to give the domain and the range. Actually, the domain is the best place to start. The domain's important. That's all the possible inputs of your function. Well, because usually it's been all real numbers for us, but with square roots, we can't take the square root of a negative. So this value in here, x, has to be greater than or equal to 0. It cannot be negative. That's our domain. So now we're going to make a table of values. And the reason we found the domain first is because we know that 0 is the smallest input we can use. So let's start at 0. We'll take the square root, or -2 times the square root of 0 is 0. And then let's plug 1 into it, because we can easily find the square root of 1. Okay, -2 times the square root of 1, or -2 times 1 is -2. What value are we going to plug in next? We could plug in 2, but I wouldn't do that. Let's use a value that is easily taken the square root of, like 4. Okay, so -2 times the square root of 4, or -2 times times 2 is -4. And then likewise, let's use another perfect square like 9. -2 times the square root of 9, or -2 times 3 is -6. And what we've got here is an input-output table of values. We can easily plot all these values and get a graph. But first, before we do that, let's identify the range. We can tell that it starts at 0 and goes down from there. So our range, our outputs, are all values starting at 0 and going down. So y is less than or equal to 0. So let's graph this. 0, 0, plot that. 1, -2, 4, -4, and 9, -6. Draw a nice smooth curve, and that is what the graph of a radical function looks like, or square root function. Okay, let's do this again. This one's slightly different than the last. We don't have multiplication, we've got subtraction going. We will start off by identifying the domain though. This value in here, x, has got to be greater than or equal to 0. So now when we make our table of values, we know to start out at 0. Okay? Square root of 0 minus 1 should be -1. And then how about we take the square root of 1 minus 1, which would be 1 minus 1, should be 0. Let's jump up to 4, because that's a perfect square. Square root of 4 minus 1, or 2 minus 1 would be 1. And let's use another perfect square like 9. So we got a table of values complete. Now we can determine what our range is. It's all values of y greater than or equal to -1, because you can see our first y value is -1, and then it goes up from there. So start out by determining the range, make your table of, or I'm sorry, the domain, make your table of values, and your table of values should tell you your range, your possible outputs. And then let's plot our table of values here. 0, -1, 1, 0, 4, 1, and 9, 2. And draw a nice smooth curve to represent all the values that work in this function. You know, if you did plug in 2, you're probably going to need to use a scientific calculator to get the output. It's some kind of irrational number right there between 0 and 1. All right, let's do another one. This one is slightly different again, because the inside of the radical has a little bit more going on there. So our domain this time is actually x plus 2 has got to be greater than or equal to 0. Again, you can't take a square root of a negative number, so this entire quantity has got to be greater than or equal to 0. So then we solve that inequality by subtracting 2 from both sides. And we get that x is greater than or equal to -2. So our domain is that. All our inputs have to be -2 or greater. So that's where we'll start our table of values. So when we plug -2 into the function, -2 plus 2 is 0, and the square root of 0 is 0. Now we need to be careful here on the next thing we want to plug in because we want it to be a perfect square. So let's see, it's got to be greater than -2. If I plug in -1 though, this should work. -1 plus 2 is 1, and the square root of 1 is 1. All right, now the next number I'm going to plug in, if I plug in 0, I'll get 2 inside, and that's not a perfect square. If I plug in 1, I'll get 3 inside. That's not a perfect square. But if I plug in 2, I'll get 4, and that is a perfect square. The square root of 4 is 2. So it's not that I can't plug in numbers between -1 and 2. It's just that they come out irrational, and it's tough to plot those. But if you want to use a graphing calculator and get numbers in between, that's fine. The last number I'm going to plug in is 7, because 7 plus 2 is 9, and the square root of 9 is 3. Again, I can plug in 3, 4, 5, 6, and any fraction in between there, but it's going to come out irrational, which is tough to plot. So our domain is, you can tell by the outputs here, all values of y greater than or equal to 0. Let's plot our points. -2, 0, -1, 1, 2 and 2, 7 and 3. And that curve is our graph of all the ordered pairs that work in this function. All right, so let's see if you get the pattern. Same process here. Give it a shot. Press pause. When you press play, my solution will appear. Okay, so our domain is going to be x has got to be greater than or equal to 0. So I'm going to plug in some perfect squares like 0, 1, 4, and 9. That'll determine my domain. It starts at 3 and gets bigger, so I'm sorry, our range rather is all values of y greater than or equal to 3. We'll plot our ordered pairs 0, 3, 1, 4, 4, 5, and 9, 6. And we're done. Make sure that your curve doesn't extend beyond this point because none of these points over here work. It starts right here at 0, 3 and goes on from there. Give this one a shot. Again, press pause. When you press play, I'll have my solution for you. All right, a little bit more to think about when you do the domain of this one. It's x minus 1 is greater than or equal to 0. Solve that and you'll get x is greater than or equal to 1. So those are the only inputs you can use, 1 and up. So I'll use 1 and 2 as inputs. Then I'm actually going to use 5 as an input because 5 minus 1 is a perfect square. And I'm going to use 10 as an input because 10 minus 1 is a perfect square. I thought I was going to use 11, but I was wrong. I'm going to use 10. So our range then starts at 0 and goes up. So all values of y greater than or equal to 0. Plot my points, 1, 0, 2, 1, 5, 2, and 10, 3. Draw a nice smooth curve starting at 1, 0, and we're done. So that's all there is to it as far as graphing radical functions. The domain and the range seem to be, confusing for some people sometimes. Watch it again if that's an issue for you, and also what inputs you should use. Remember, you can use anything you want. It's just some things are easier to do in your head than others. So give that a shot, and we'll help you out tomorrow if you have any questions. Have a great night.